Okay, so we're talking about how to find the x and the y intercepts with a parabola that's in a factored form, or it's in its general form. First of all, to find the y-intercepts, I didn't have any examples, so I'm just going to say that first. If I want to know what the y-intercepts are, I let every value of x be 0, and that'll give me my y-intercept, where it touches the y. Okay, so when we talk about factored form, we're looking here. This is the standard form of this equation. And then when we factor it, we have two basic line equations or linear equations. So when it's in factored form, this gives us the ability to find the x-intercepts. So the following steps are utilized to find the x-intercepts of a parabola that's already in factored form. But let me repeat it too. If it's not in factored form, you have to factor it to get it in that form. Okay, so here we have a problem. In this case, this equation, or this graph, let me put a y here. It's actually y equals x plus 3, x plus 2. So we want to take each factor, and here's one factor, and here's two factors, and set them both equal to 0. So here we have it in factor form already, so all we have to do is set them both equal to 0 individually. And next we solve for both line equations. So here we have x minus 3 equals 0, so this is going to become x plus 3 equals 0, so this will become x is negative 3, and this will become x plus 2 equals 0, x will be negative 2. So remember, we're talking about the two places on the graph where the parabola touches the x-axis. So down here we have the parabola, negative 3, 0, so let's look at that. So this is your negative 3, 0, and this is your negative 2, 0. Okay, so the y value for every x-intercept will always be 0. The x value for every y-intercept will always be 0. Because when you're talking about the y, I'm looking for the y-intercept. If I happen to, I'm going to say the graph looks something, let me just do something like this. Okay, so we want to know what the y-intercept is. When does it touch the y? But notice if we're looking for the y-intercept, if we're looking up and down here, up and down there, your x value is always going to be 0. Just like if you have an x value over here, let's just say this point, let's say this point is 2, 0. The reason it's 0 because we're not moving up or down on the x-axis. And the same way that accounts for the y-intercept too. Okay. So remember, to find the y-intercept, we set every x value in the equation, and we put wherever an x value is in the equation, we put it as 0. And when we solve for that, we'll know what y is. Here, we found the x-intercepts. So at negative 3, 0, and negative 2, 0. Okay, so here's an example. We have y equals x plus 5, x plus 2. So set each factor equal to 0. So we set both of them, x plus 5 equals 0, x plus 2 equals 0. Then we solve each linear equation, or we could call it a line equation. So x equals negative 5, comma, and x equals negative 2. So the x-intercepts are at the points that touch or cross the x-axis. The y-values at these points are 0. So in this case, we have negative 5, 0, and negative 2, 0. And keep in mind, too, if we wanted to know the vertex, we could find that out, too, and a few other things. Okay, so here we have another one. X squared minus 10x plus 16. Okay, so this parabola is in general form, so we have to get it in factored form. So first we factor the parabola. When we do, we get x minus 2, x minus 8. Next we solve each line equation. So x minus 2 equals 0, then x equals 2. X minus 8 equals 0, then x equals 8. So after solving both line equations, aka linear equations, we have the x-intercepts at 2, 0 and 8, 0, respectively. Okay, example 3. Y equals x minus 9, x plus 2. Once again, it's already in factored form. So we have to set both line equations equal to 0 and then solve for x. So our first x minus 9 goes down here. X minus 9 equals 0. Then x equals 9. X plus 2 equals 0. X equals negative 2. So again, these are your x-intercepts, where it is going through the x. Now, if we were going to find, just quickly, if I wanted to find the y-intercepts, we said we have to make every value of x 0. So if I had this as 0 here, and a 0 here, and I multiplied negative 9 times 2, we would get negative 18. So that's where it would touch the y-axis at negative 18. And notice how this just keeps going down. Okay, another example, x squared minus 9x plus 8. Here we have the parabola in general form, or the quadratic function. First we factor the parabola. So y equals x minus 1, x minus 8. Next we set each line equation to 0. So we factored, we have x minus 1 equals 0, and x minus 8 equals 0. So now we solve both line equations. We get that for x minus 1, we get equals 0 of x is 1. X minus 8 equals 0. X is 8. So once again, our areas, our x-intercepts is going to be 1, 0, and 8, 0. And again, the reason the y's are 0 is because you're talking about if it's just touching the x-axis and hasn't moved up or down, then that y value is going to be 0. Okay, so the last one, y equals x squared minus 31x minus 20. Okay, so the parabola is in standard form. Y equals ax squared plus bx plus c. But we need it in factored form. So we take our parabola and factor it. And we find out it's 7x plus 4, x minus 5. Now we take both of those little miniature linear equations and set them to 0. And then finally we solve the equations. So 7x plus 4 equals 0, x equals negative 4 sevenths, x minus 5 equals 0, x equals 5. So negative 4 sevenths and 0 are your negative 470 is one of your x-intercepts, and 50 will be another x-intercept. So remember, if we want to find the vertex of the parabola, this point here, we'll say x, y. We use the vertex formula, which is just given by x equals negative b divided by 2 times a. We plug in our values, whatever, we write this general formula of the parabola out, ax squared plus bx plus c. In case we identify our b, that goes in here. We identify our a, and that goes in here. And so that gives us the first x value, and we solve for that. Then we take whatever we got for x here, and we plug that value back in for each x. And this will give us our y value. Now we know if we're looking for the axis of symmetry, or the axis where the graph of the parabola is broken up into 2 equal halves or congruent, all we need to do is use this right here. We find our b, we find negative b divided by 2a. We plug our a and our b in here. And then once we find this value here, well, as you can see, this x minus b over 2a is actually a special equation of a line. So we solve that, whatever we get for x, this would be our axis of symmetry. And then remember, the graph going down is going to have a minimum here. The graph going up is always going to have a max. The general domain of a parabola is negative infinity to infinity. The range for the parabola is going to be 0 to infinity. Now, if it's a regular parabola centered at 0, like y equals x squared, that starts at 0. But it could be a parabola that's shifted up more or shifted down, and so this 0 can fluctuate.